I don't want you guys to look down on me, but I don't know what the zenith gradient algorithm is. Okay, I did do back propagation gradient descent algorithm, but I don't know what the zenith gradient algorithm is. Is it? Am I stupid? Unfollowed? Fuck. Senior engineer here, everybody. Oh man, dude. Anyways, I want to tell you guys something. I bought Medium. I pay a monthly service charge, dollars a month, so that I can read articles to you. And I hope that all of you are happy with my decision. I pay for Medium. Motivation. Let's say you have 4 tasks to do in a given day. Work on an essay, do some math homework, edit a video, do some math homework. This guy clearly is doing his math homework over here. Isn't that free? Isn't there freedom? I don't know if there is freedom. Anyways, edit video and study for physics exam. And let's also assume you have 6 hours in total to spend on all these tasks. The question is, how should you best allocate time to each one of these tasks to maximize your productivity? Simple. Do one at a time that's most important. Why would you ever do anything else? Because you're going to waste time trying to figure out how to do your task. People that get stuck in analysis paralysis because they cannot figure out what is the most important thing to do is just absolutely silly. Just do the simplest and most straightforward thing ever, which is do the one that's due the first. Like, that's it. Just do whatever is first. Because they can't all be due at the same time. Like that, there's just not a possibility. You know what I mean? There's just not you cannot have a physics exam and math homework and editing a video and working on an essay. They can't all be due at the same time. It's just not possible. It's just not possible. Okay, it could be possible. Well, I mean, it'd be really hard because it's the exam, because that's a real-time thing. You know what I mean? It's just real time. It'd be very hard. Let's see. A rudimentary approach would be to allocate time arbitrarily or allocate an equal amount of time to each task without taking into account any factors like difficulty of the task, etc. Yes, and this would be called being a rookie. Okay? That's a rookie move! In this case, you could simply allocate 1.5 hours to each task and call it a day, but could you do better? What if instead allocate 1 hour of working on the essay and 0.05 or 0.5 hours for the math homework, 2.5 hours for editing a video, and 2 hours for studying physics? You could spend a total of 6 hours, but would this be better? I.e., would it be more productive? How can we quantify these decisions? How could we build a to-do app that does this computation for us? Defining productivity for a given task, P of T, or however you say it. Is that row? Am I looking at row there? What are we looking at? That's not row. What is this thing? That's no standard P. What is this one? Is it row? It is row? Okay. Okay. I'm already lost. Lil P, bro, that's P. It's not row. That's a P, bro. That's not row. I don't know, man. Be the amount of progress we have made at the time T. Then productivity, P of T. See, this is P. That's P. See, there's a difference. That's row. That's P. Can be defined as the amount of progress being made per unit time, i.e. P of T equals the, this is just straight up differentialing row with respect to time. Productivity is the time derivative of progress. If we make a lot of progress really quickly, then we are more productive. If our progress doesn't change with respect to time, then we aren't productive at all. So this is a reasonable definition for productivity. It is. Nice. Okay, we're bringing fuck you. We're bringing in a little bit of calculus 1. Let's go. I like this. Finding a model. While doing a task, productivity as a function of time naturally has the shape of the Poisson distribution. It starts at some initial value, then increases to some maximum point. This can be the mathematical definition of flow state, i.e. flow state can be defined as the time when we're most productive, then decrease as we lose energy. Yeah, some of us kind of, I personally feel like I've taken one of those little blue pills except for productivity, okay? I stay erect. Okay, there's no, when I go, I step function. I'm on, and I go, and I go, and I go, and then I turn off because I have to build JavaScript, and then I hate my life. It's not Adderall. The blue pill is the one that, you know what I mean? Gets the blood flowing. You know what I'm talking about? Or the blood not flowing? Which one was, is it the blood flowing or the blood not flowing? Is it blood flowing to stop the flow? To staunch the flow, as one would say? Blue steel, crackhead energy? We're not even sure. All right, anyways, let's keep on going. Then decrease as we lose energy. A good model for this type of behavior is the function. All right, our productivity at time is P0 plus, I'm not sure what A, T, and E stand for yet, minus KT. I don't know what K, E, and A stand for. I assume T is time. Okay. Okay. Oh, is this some sort of alpha? Are we looking at it? Isn't this called an alpha beta distribution? A and K are constants. A K constant. T is time. Well, what about E? Is E effort? Is E effort, or is E the natural that delicious natural number 2.7 something some shit? You know what I'm talking about? Euler's number. Euler's constant. Bro, I thought it was Euler. Yeah, guess what? You could Euler these nuts. It's Euler, baby. This curve can be parameterized by the effort of the task E, the enjoyability of the task beta, and the time it takes to reach flow state. What is this one? Is that omega? What is that guy? Is that omega? I'm not good at all these ones. It's not a little omega, and it doesn't look like that's not omega. What is that? Is that phi? Phi? Yeah, phi. Got it. Whew. Whew, I got close there. I almost effed that one up. I almost effed it up, closed my eyes, and bam. First time here, heard from Pirate Software. So far, the stream has not disappointed. You're a funny dude. Hey, thank you. Yeah, I would just like to say that sometimes my humor can get people a little riled up on the internet. Okay, they can kind of get a little bit angry. And that's it. That's all I really wanted to say. Sometimes I like to rustle some jimmies. You know what I mean? Sometimes I like to trigger the libs. You know what I'm talking about? I like to pwn the conservatives, own the libs, trigger them all. As mentioned above, flow state can be defined as time when productivity reaches a maximum. To calculate this value, we can set the differential of productivity with respect to time equals to 0 and solve for t. This calculation results in t equals 1 over k. We can now set this value. I don't know how they got there, okay? Okay, I feel like someone's not showing their math homework right now, because I'm not sure how you just went with this with respect to time and then just got a k out of it. Okay, I'm not sure what k is. I'm not sure how this happened. Okay, I don't know. We can now set this value of t equal to phi to solve for k, which results in k equals 1 over phi. I don't even know how you got to that value, which means that t equals phi. My goodness, t equals phi. Based on what I'm looking at, the t is equal to the phi. We can express phi as a function of e and beta. All right, phi takes in these two parameters, effort and the task we're on, or enjoyability and the task we're on. Okay, this makes sense. Pinpointing this function exactly would be complicated. Instead, we can approximate phi as a linear function. That makes sense. There's some coefficient of enjoyability plus the coefficient of the task we're currently on plus some sort of constant offset. Okay, that makes sense. This looks like a lot of circle joiking. Yeah, it is. The coefficients 1 through 3 are constants that vary from person to person and are within range such that phi is greater than 0. Okay. Oh, interesting. So I would not have thought it was varying from person to person. I thought it would. It would be it would be kind of like a cross product of person. And I personally thought that E would almost be related to beta. I'm a little surprised that E is not related to beta here, because, there should be a P in here as well. And I do think E should be broken down. I think E really is beta P. Can we be real here? And by P, like capital P, person. It only makes sense because the enjoyability is dependent on the person and the task. Let's get some partial derivatives on this son of a bitch. The initial productivity P can be defined by the task squared over the enjoyability squared. I hope I got the E correct, that it's enjoyability. We typically have a harder time starting higher effort. Oh, E is effort. Interesting. Okay. Well, effort again is still related by person and task. It's true, because he even states it right here. We typically have a harder time starting higher effort tasks compared to lower effort tasks, and hence our starting productivity decreases as the effort of the task increases. I guess that does make sense. All right. Increasing the parameters A increases the global maximum of the function and hence increases the value of our peak productivity. By the way, you can definitely tell. I feel like a college student wrote this, because only a college student would still be so deep into this. 10 years into what am I at? 15 years into the real world, and I'm just like, yo, dog, I can't remember none of this shit. We can try to quantify how A depends on the parameters of effort and task by thinking of how our peak productivity flow state changes depending on the effort of the task and how much we enjoy doing it. Let's use a video game as an example. When playing a low-effort video game, the flow state we experience won't feel that much different than how we feel on a regular basis. In contrast, when playing a high-effort competitive video game, the flow state we experience will feel almost magical compared to any other time, especially if we really enjoy the game. Yeah, that's true. Elden Ring, you really get into Elden Ring, it feels real good. I could feel that. I could feel that. Dota player confirmed. LOL. League player, probably still in Bronze League. What's up, Corgi? This tells us that higher effort tasks that we really enjoy correspond to higher peak productivity. A good model for this would be this function. Alpha is the task squared, the natural log of effort plus the task squared. I'm not sure how you got to this model. I'm just going to throw that out there. I'm not sure how we got to the model. Putting this all together, we have the project with the input of time equals the initial getting over the hump plus all that shit, which is a replacement for A, multiplied by T, the Euler's constant, to negative T divided by the interpersonal effort project 1. Okay, it seems good. Seems reasonable. In the previous section, we've defined the time it takes to reach flow state as phi. So we do this, all right, where C are constants that vary from person to person. So for phi to be non-negative, we can define a fixed range of E and B, or E and beta. We can define some intermediate variables, EU and beta U, to be effort. To be the effort and enjoyability, respectively, that the user provides. For consistency, both of these values will range from 1 to 10 and will be mapped linearly to their respective ranges, i.e., E, the true value of effort, is a linear function of EU, and B, the true value of enjoyability. Oh, I thought he stated earlier that beta was not enjoyability, but the specific task we're on. Okay, I guess I've been reading this whole thing wrong the whole time. Is this article just a dumbed-down thesis? It really is. Experimentally, it was determined that the good range for E is this right here, 1 through 5. We can now linearly map the range of EU, the intermediate value of effort, from 1 to 10 to 1 to 5 using the following function. What is this? Are you trying to... Okay, first off, it looks like you're trying to get Fahrenheit out of this bad boy. Or Celsius out of this. I don't like what I'm seeing right now. Anyways, the boundary of enjoyability. I didn't realize we are in freedom units of effort, and now we're converting to metric effort. It's bullshit. What's happening here? Similarly, a good range for enjoyability is 1 to 2. We can linearly map the range of enjoyability U down from 10 to this, doing this with this one. Okay. User-dependent contents. Now we'll explore 1, 2, and 3 to, can be determined. For each task I, a stopwatch can be used to measure the time until flow state. Phi, the time it takes to get in the zone. This will give us the data points. Bam! Where E sub I is the effort of task I, and B sub I is the enjoyability of task I. We can then use a linear least squares approximation to find the best fit plane to the data, which results in this. Damn, man, this look good, man. Not gonna lie to you, this little sum right here is just N. Okay, just like looking at this really quickly, you're going from I's 1 to N. Just return. That's just N. You didn't even have to do that, and therefore I'm out. Constants 1, 2, and 3 will be updated after a new data point has been provided. When to stop doing tasks. Let's assume you have the task of studying for a math exam, and you've determined that the effort of this task is on a scale from 1 to 10 is about 7. That means a 3.65 in, that's a 7 in freedom units, by the way, so don't get confused. The enjoyability is a 3, so that's a 1.22. Let's assume that the user-dependent constants are the following, and your estimated time until flow state would then be 1.75 hours. So your productivity curve looks like that. Nice. Now, the question is, how long should you spend time doing the task to maximize productivity? If you study for too long, you will become burnt out and start experiencing diminishing returns. I used to be able to study math for like 16 straight hours. I don't know about this whole so-called diminishing returns business. Sometimes you just got to, you know what, I'm going to throw something out there that's going to make people angry. Are you guys ready for this one? Sometimes you just got to be more mature than how you feel, okay? I'm just throwing it out there. I know this may be a little hurtful. I know that I just injured people, okay? I know some people is just like that one thing with the girl spitting knives and the guy going, ah. Being more mature than how you feel is difficult, but I'm just saying it is really good. You have to be healthy to do that. You know, you can make all the excuses you want. Okay. I love it. My favorite thing is when you say that, there will always be somebody that says, "Well, actually, you know, my condition is unique. I can't do that. I'm unique. I'm a unique one, actually. Just saying, actually." A study for a little too little and you risk not getting enough value out of that session. There's a sweet spot, and intuitively we know it lies sometime after you reach flow state. But how long? To answer this, we need the measure. We need a measure of how productive you are on some time interval. For the sake of the example, let's say the first 30 minutes of studying into studying. A good measurement for this average of P of T would be between T of 0 and 30 minutes, which can be calculated by this classic measuring the area under the curve. Everybody knows about this. And luckily, these are all constants, right? This would be everything in here is a constant because we said, it goes from 0 to 0.5, right? So that's like, I feel like that's not too bad. We can compare this for a later time. I feel like back in my days, I could have done this maybe. I don't know. That whole negative T up there, maybe I would have struggled. We need some sort of Taylor series, don't we? We can compute this to a later time interval, let's say between 8 and 8 hours, okay? All right. We can see, as we can see, the first 30 minutes into studying was not much more valuable than 30 minutes a couple hours later. We can now define, as you can see, by the way, for those that don't know, for those that couldn't just immediately tell, you actually don't, it's obvious, okay? QED. You just know this. All right. We can define the global maximum for this function to get the optimal time you should be studying spend studying to maximize productivity. Just give the man his master dissertation. Okay, just let him pass. He wins. Okay, hey, he wins. Let it go. Just let it go. LaTeX much? LaTeX for days. Solving for T numerically, we find that T is 3.16, so the optimal amount of time you should spend studying is 3 hours and 10 minutes. All right, generalize. If we have N tasks to complete in T hours and we're given the following, and an effort vector of this, and the enjoyability vector where E sub I is the effort of task I and B sub I or beta sub I is the enjoyability of the task I, we can define the following phi like this, blah, 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 which goes all in here, a lot of vectors here, and let P of T be the total productivity for the day where T equals all of these numbers, and Ti is the time spent doing task I. Therefore, capital P of T can be defined as the sum of average productivity for each task. All right, there we go. Now we can now we can maximize this function under the constraint that this right here happens. Okay. Using the method of Lagrange multipliers, we do this. Classic Lagrange multipliers. Classic, really, when you think about it. Oh, did we actually get we're partial derivating the chain rule. We're about the chain, boys. Boys, we're chain. Math stream, solving the system of equations. Let us revisit the example where we started with you have 4 tasks to do in a given day. Work on an essay, task 1, to do some math homework, task 2, edit a video, task 3, and study for a physics exam, task 4. And let's assume that you have 6 hours in total to spend on all these tasks. The question is, how should you best allocate time to each of these tasks to maximize productivity? Each of these tasks have an associated effort and enjoyability we can define right here. All right. I do have a fundamental flaw he has not thought of, and I would like to talk about it, but I'm not going to talk about it yet. This is also E of all these things with all these different enjoyability and effort ratings. Therefore, we have all these nice little delicious vectors that are going through, assuming some constants right here. Solving this system of numerically results in the following of 0.7, 1.84, 1.1, and 2.35. So to maximize your productivity for a day, you should spend 0.7 hours, 42 minutes on working on the essay, 1.84 hours, an hour and 50 minutes doing math homework, 1.11 hours, 1 hour and 7 minutes editing a video, and 2.31 hours, 2 hours and 21 minutes studying physics. Now we compare this to a rudimentary approach mentioned at the beginning. Where would you arbitrarily allocate time? For example, let's say you allocated 2.45 hours for the essay, 2 hours for math, 0.5 hours for video editing, and 1 hour for studying physics. All right, we did all this. Look at all these P's. We got a lot of P here, which means that you would increase your productivity for the day by about 19% using this model. 19% increase. Sanity check. We're still going. If you have a list of tasks to complete that have all the same level of effort and enjoyment, intuitively, we would expect it would be best to spend an equal amount of time on each task, since there would be no reason to prioritize one task over another. Mathematically, this makes sense that if we solve a nonlinear system above with the same thing. Okay. Where all of this happens, awesome. For the sum value of this, okay, fantastic. Proof is left as an exercise for the reader. Hit him with the QED right there. Final product. I've been developing this app for almost 2 years. The model described above has been fully implemented, and you can try it out for free. I actually might try this out just to see how it goes. The demo of the app can be viewed right here. Dr. Tom Crawford from the book Tom Rocks Math YouTube channel has also made a video covering this algorithm. Nice. Let's go. Let's go. That's absolutely fantastic. All right, are you ready for me to hit you? Hit you with some knowledge? Okay, I do have one problem. Okay, I actually have two problems with this person's graph. First off, if you want to be successful in life, real talk, don't have a morning routine. All right, I'm just throwing that out there. Don't have a morning routine. Get up and get to work. Okay, don't hit that red light therapy, jump in that cold plunge, do all that stuff. Get up, get to work. Stop it. Just go immediately. Wake up, coffee, go. Okay? Just throwing that out there. Okay, a lot of people do this. A lot of people do this, you know. It's an Alex Hermosi take. Alex Hermosi has this take where when he was getting his gym up and running and doing all that, he would just get up and work and do it nonstop. And then when he got a bunch of money, he would start doing all these different morning routines, and he realized his productivity massively dropped. And the reason why is that when you become wealthy, you stop caring so much about your productivity. So therefore, you now just do it easy route, right? You got that red light therapy shining on your balls, blah 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 blah. There you go. Anyways, okay. Second off, here's a problem that I have with this. The reason why I think this is fundamentally broken is that there's one assertion in here that is incorrect, which is that they do not, it's right here. Let's just take this graph for a quick second and let's save it, okay? I'm going to call it graph, WebP. Nice job. Nice WebP, bro. We're going to discard. And I'm going to open this up. I'm going to open this up right here. You guys are going to see this immediately. Are you ready for this? So I'm going to take this. This is a well actually moment. Are you ready for this? I'm going to create a new one of these. Okay, we're going to create a new one. Same size. And I'm going to go like this. And I'm going to take this right here. And I'm going to approximately cut this in half. Okay? Approximately. I'm going to copy it. And I'm going to do that, and I'm going to do that, and bada bing, bada boom. And then I'm going to paste it one more time. I'm going to create another half right there. And then we're going to go right here. And so I want you to look at it more like this. All right? And then I'm going to take this color. I'm going to zoom in and try to get the closest I can to that color. And then I'm going to take this guy right here, and I'm going to drop it down to some smaller. Now, this is not small enough. And actually, let's create one more thing right on top. And I'm just going to put it right here, and I'm going to go like this. All right? So there we go. This is not booba or booty. Okay, neither. This right here, this range right here is what I like to refer to as the trough of sadness. When you go from one task in which when you're hitting that flow state to a new task, there is what truly does happen, which is not being mentioned here, is what I would like to refer to as here. I'm going to go in here and I'm going to take this and I'm going to actually increase the width by a good amount. We're going to resize this. I'm going to take this one right here and I'm going to actually move it over here, right? And then I'm going to take we're going to take the eraser really quickly. We're going to jump back to this one and I'm going to increase the size of it real thick, right? And I'm going to just erase all of this, right? And then I guess there's more erasing that needs to be erased. There we go. And then this one also. So there we go. So there's the line going straight down. And what ends up happening is that now you've reached a whole new problem, which is he does talk about a startup cost, but startup cost he defined as effort over enjoyability. I might be wrong on that. It might be enjoyability over effort. Yeah, that makes more sense. It was enjoyability over effort, right? The problem is it's not actually that. It actually is the cost of breaking previous flow state. So it's also the previous flow state breaking cost. And so this trough of sadness lasts really long, because what ends up happening, this is where things get really intense and a lot of people don't understand, is that when you're doing a task and you hit flow state, this also probably represents your dopamine. You're getting hit with dopamine. You're feeling good. And when you stop, bam, you're feeling the effects. Okay? Now you're dopamine trowed hard, right? You're hitting the bottom of the bottom. And so just to like imagine that your startup cost is only based on the enjoyability and effort to get into the next task is not real. You're also fighting a dopamine crash from leaving one flow state to the next. Now, there is a difference though. There is a big difference. There's something that is also not stated in this, which I think is really important. At some point deep down this curve, when your dopamine has already crashed, but you're still pushing through it, well past the curve of productivity, right? You are pushing through because you are mature. At this point, starting a new task gives you bonus dopamine, right? You've been trowing hard, pushing through, being mature, taking all the right steps, and then when you start a new task, it's almost like you get a supercharge, right? You like explode up in productivity because you're doing something different after so long. So there is definitely like, it's not, the problem is, the fundamental problem is that he measured it as enjoyability over effort, right? And there may be squares in there as well. I cannot remember. But there is a third factor, which is the distance from the previous task and how far past the point of prime did you go, right? Like the point of dopamine crash, how far past did you go? Because you have to go far enough into the misery section of doing that task for you to really launch off into the next one. You know what I mean? Dick to dick ratio. This man gets it. All hail King Julian. No, sorry, no, that pigeon guided missile gets it. I hate how right you are. Yeah, I'm just letting you know. As a man who's very productive, one of the secrets is that you have to go far enough into it. After some sleep deprivation, something like 24 to 36 hours, there is a demonstrated longer period of flow state. Really? That sounds awful. Moral of the story, booba equals dopamine? Absolutely. Moral of the story is booba, dopamine, but clavage, trough of despair. So anyways, be careful. Be careful about switching tasks too fast, okay? When you're in a good flow state and you break it, you're going to crash hard and it's going to be unenjoyable because you're going from an enjoyment state to an unenjoyment high effort state. When you're in a already high effort state and you can no longer derive any enjoyability from it and you last long enough in the high effort, low enjoyability state, the change up can give it to you. I actually think this is an equation for burnout. Real talk, I think this is an equation for burnout, which is you can't stay too long in that long tail. You know what I mean? Like there's a point of burnout that happens at some point when you've made it way too long and you need to be able to switch tasks. And I feel like this is where a lot of people actually experience burnout. I think we've mathematically solved burnout here. I truly do. Obviously, this is only work-related burnout. I'm not talking about personal life-related burnout, which is very, very important. But this is why I suggest side projects so often, is that at this point, when you finally reach this really difficult stage, when you have such high effort and such low enjoyment coming out, you need to go do something that yields high enjoyment and low effort. Like, that's one of the reasons why we did that stupid video. What was that, dude? What was that? The last video I did. It was just like such low effort, fun take for me. 2,300 devs versus me trying to program faster. Like, for me, this was just like the funnest thing. I just had so much fun. It was such little effort, and it made me, like, honestly, the rest of my day working at Netflix was literally multiples more productive because I had so much fun building something stupid. Yes, AKA this is also why democracy doesn't work. That was rigged. I know, no doubt. Well, we fixed it. So there you go. I like this article. Great article, by the way. Great article. Who did this? Who wrote this? Because you deserve some sort of follow. All right, do you, Jaheim, do you have if that's how you say your name, do you, Archibald, Dr. Archibald, do you have, here, I'll follow you. I don't follow anybody. There you go. You got my first follow. But if you have a Twitter somewhere, I would gladly promote it if you whisper me. This is absolutely just dynamite. Might I add? absolute dynamite. Arch user, you think so? Well, I can't help. But hey, great article. Good job. Absolutely loved it. I do feel like my little contribution to your thesis was true, that you definitely have to try to figure out how to include a cost of switching into your formula. If you make a follow-up that's just the math about that and how it changes it, I'd be glad to read it. You know what I mean? Yeah. And then, someone's linking the app link. Very awesome.